All right, here is another multivariable linear approximation. We're going to use a linearization of f of xy equal to 2x plus 3 over 4y plus 1 at the point 0, 0 to approximate 3.08 divided by 1.04. And so the thing I've made slightly more challenging about this problem is we have to figure out what the x and the y values x are. Now we know that they should be close to 0, 0. Really we're just trying to see what does x need to be so you get 3.08 on top. What does y need to be so you get 4.01 at the bottom? And the answers are, well, x needs to be 0.04, because 2 times 0.04 is 0.08, plus 3 is 3.08. And y needs to be, well, 1 plus, I'm trying to get 0.04, so y has to be 0.01. It's 4 times 0.01 is 0.04. So that's what we're trying to evaluate, or approximate, I should say. So again, the linearization formula, well, actually before I did, let's find the partials. So fx is actually easy. Fx is, so here's how I'm seeing this. I would really, well, I don't want to use the quotient rule because I don't have to use the quotient rule. It might make it easier if I rewrote the function f of xy as 2x plus 3 times 4y plus 1 to the negative 1. Because then the partial with respect to x is, well, the derivative of this is 2 times this constant, right? There's no x's there, that's just a constant. Fy is a little bit more challenging, but not a lot. This is the constant now, right? There's no y's in there. So the 2x plus 3 that's multiplied by this function y hangs out. And the derivative of this is a little more complicated. It's negative 1 times 4y plus 1 to the negative 2 times 4. Right, because you can multiply with the derivative of the 4y plus 1. And hopefully you guys can see that all right. And then we have to figure out what each of these are evaluated at our point. But luckily the point's really easy, right? Now if you were given this and asked to do linearization, you would say, oh, they want me to linearize at 0, 0, because that's the easy point that's close to the point they're giving you. But they gave it to us to start off with. So I need to find fx at 0, 0, which is just, well, if I plug in 0 for y, I get 2 times 4 plus 1, sorry, not 4 plus 1, 0 plus 1 to the negative 1. 1 to any power is 1, so I just get 2. Fy of 0, 0 is, so I'm going to plug in 0 for x and 0 for y, I'm going to get 3 here, times, let's see, negative 1 times 1 to the negative 2 times 4. This is looking like, again, 1 to any power is 1. So I've got 3 times negative 1 times 4. That looks like negative 12. And finally, our function evaluated at 0, 0, right? F of 0, 0 is 3 over 1. So our linearization, before we try to do an approximation, our linearization at x comma y is fx times x minus x naught plus fy. Sorry, I usually write, sorry, I forgot the first part. Usually write that part first. It's f of 0, 0, 3 plus fx, which is 2, times x minus x naught. X naught is 0 here, right? This is my x naught, y naught, plus negative 12 times y minus 0. Right, so let me write that in red just so you guys can see, right? This is my f of x naught, y naught, plus fx times x minus x naught, plus fy times y minus y naught. Technically it's fx evaluated x naught, y naught. Sometimes people will leave that off. This is fy evaluated x naught, y naught. Sometimes you write f of x naught, y naught. Sometimes you write f vertical line x naught, y naught because it saves space. But it means the same thing. So here's my linearization, which I'm going to simplify down to 3 plus 2x minus 12y. So it's kind of interesting that this quotient function here has a linearization. Well, I mean, it should be a linear function, right? That's why it's called a linearization. The linearization should always be something that's linear in x and y. And then if I want to approximate f of 0.04 comma 0.01, it's going to approximately be the linearization at 0.04, comma 0.01, which is going to be, let's see, 3 plus 2 times 0.04 minus 12 times 0.01. So I've got, let's see, 3.08. Sorry, I'm fine. 3 plus 0.08 minus 12 times 0.01 is just 0.12. So overall it's 3 minus 0.04, which is 2.96. Which makes sense if we think about it. 3.08 divided by 1.04 should be a little bit less than 3, because 3.08 isn't quite 3 times 1. I figured out how to use the calculator this time. So if I do 3.08 divided by 1.04, I get 2.9615. So yeah, a good approximation there. All right, so there is another example of doing a multivariable linearization. Hopefully that will help you guys out. Bye.